Let's do some example problems here. So we have the perimeter of each of the outer triangles is 30. So for example, if I took the sum of this side, and that side, I will get 30. And that's true of all of these outer triangles, these 5 outer triangles. They then tell us that the perimeter of FGHIJ, so FGHIJ, the perimeter of this pentagon right over here is 50. So if I add up that side, plus that side, plus that side, plus that side, plus that side, I get 50. And then they say, what is the perimeter of the star? So the perimeter of the star is really the outsides, if you take the bases away, of each of these triangles. So it's this side. Let me do this in a new color, actually. So the perimeter of the triangle, I'll do it in orange. It's going to be this, plus that, plus that, plus that, plus that, plus that. I think you get the idea. Plus that, plus that, plus that, plus that. So the perimeter of the star, so let me call this the perimeter of the star, is going to be equal to the perimeter of the 5 triangles, is equal to perimeter of 5 outer triangles. I'll just call them 5 triangles, like this, minus their bases, right? If I take the perimeter of all of these guys, if I added it up, the part that shouldn't be part of the perimeter of the star would be this part, that part, that part, that part, that part, and that part. Those aren't part of the perimeter of the star. So it should be the perimeter of the 5 triangles minus the length of their bases, length of their 5 bases. So what's the perimeter of the 5 triangles? Well, the perimeter of each of them is 30. So the perimeter of 5 of them is going to be 5 times 30, which is 150. Now, we want to subtract out the lengths of their 5 bases. Now, the lengths of their 5 bases, if we add them up, is the exact perimeter of this inner pentagon right over here. So this inner pentagon has a perimeter of 50. That is the sum of the 5 bases. So that right over here is 50. So the perimeter of the star is going to be 150 minus 50, or 100. All we did is we took the perimeter of all the triangles, subtracted out these bases, which was the perimeter of the inner pentagon, and we're done. Now let's do the next problem. What is the area of this quadrilateral, something that has 4 sides, of ABCD? And this is a little bit, we haven't seen a figure quite like this just yet. On the right-hand side, it looks like a rectangle. On the left-hand side, it looks like a triangle. This is actually a trapezoid. But we can actually, as you could imagine, the way we figured out the area of several triangles is splitting it up into pieces that we can recognize. And the most obvious thing to do here is start at A and then just drop a rock, drop an altitude right over here. And so this line right over here is going to hit at 90 degrees. And we could call this point E. And what's interesting here is now we can split this up into something that we recognize, a rectangle and a right triangle. But you might say, wait, Sal, how do we figure out what these, we have this side and that side, so we can figure out the area of this rectangle pretty straightforwardly. But how do we figure out the area of this triangle? Well, if this side is 6, then that means that EC is also going to be 6. If AB is 6, notice we have a rectangle right over here. Opposite sides of a rectangle are equal. So if AB equals 6 implies that EC is equal to 6. EC is equal to 6. So EC is equal to 6. And if EC is equal to 6, then that tells us that DE is going to be 3. DE is going to be 3. This distance right over here is going to be 3. And we know that because if this is 6, this has to be something that we add to 6 to get 9. 9 was the length of the entire base of this figure right over here. 9 was this entire distance. So 9 minus 6 gives us the 3. And now we have all the information that we need to figure out the area. The area of this part right over here, this rectangle, is just going to be 6 times 7. So it's going to be equal to 42 plus the area of this triangle right over here. Plus the area of this triangle right over here. And that's 1/2 base times height. 1/2. The base over here is 3. 1/2 times 3. And the height over here is, once again, it's going to be 7. This is a rectangle. Opposite sides are equal. So if this is 7, then this is also going to be 7. 1/2 times 3 times 7. So it's going to be 42. Let's see. 3 times 7 is 21. 21 divided by 2 is 10.5. 10.5. So this is going to be equal to 52.5. 52.5 is the area of this entire figure. Let's do one more. So here I have a bizarre looking shape, and we need to figure out its perimeter. And at first it seems very daunting because they've only given us this side, and they've also only given us this side right over here. And one thing that we are allowed to assume in this, and you don't always have to make, you can't always make that assumption, and I just didn't draw it here ahead of time just because it would have really crowded out this diagram, is that all of the angles in this diagram are right angles. So I could have drawn a right angle here, right angle here, right angle there, right angle there, but as you can see, it kind of makes things a little bit, messy. But how do we figure out the perimeter if we don't know these little distances, here? And the secret here is to kind of shift the sides, because all we want to care about is the sum of the sides. So what I'm going to do is a little exercise in shifting the sides. So this side right over here, I'm going to shift it and put it right up there. Then this side right over here, this length right over here, I'm going to shift it and put it right over there. Then, let me keep using different colors. Then this side right over here, I'm going to shift it and put it right up here. Then finally, I'm going to have this side right over here. I can shift it and put it right over there. And I think you see what's going on now. Now all of these sides combined are going to be the same as this side, where I'm kind of building, even though this thing wasn't a rectangle, its perimeter is going to be a little bit interesting, although we're going to have to think about this too right over here. Now let's think about all of these sides that are going up and down. So this side, I can shift it all the way to the right and go right over here. Let me make it clear. This orange side goes all the way to the end, right? It's just the exact same orange side. Now this white side, I can shift all the way to the right over there. Then this green side, I can shift right over there. And then I can shift this. Actually, let me not shift that green side yet. Let me just leave that green side. So I haven't done anything yet. Let me be clear. I haven't done anything yet with that and that. I haven't shifted them over. And let me take this side right over here and shift it over. So let me take this entire thing and shift it over there. And shift it over there. So before I count these two pieces right over here, and we know that they each have length 2. These are all 90-degree angles. So this has length 2, this has length 2. Before I count those two pieces, I've shifted everything else so I was able to form a rectangle. So at least just counting everything else, I have 7 plus 6. Let me say 7 plus 6. All of these combined are also going to be 7 plus 7. And then all of these characters combined are also going to be 6 plus 6. And then finally, I have this 2 right here that I haven't counted before. This 2 plus this 2 plus this 2. And then we have our perimeter. So what does this give us? 7 plus 6 is 13, plus 7 is 20, plus 6 is 26, plus 4 more is equal to 30. And we're done.